The scientific community has encountered an unexpected statement from NASA that contradicts established notions about comets. The interstellar object, named 3I Atlas, is emitting a tail directed straight towards the Sun, rather than away from it, as is customary. This tail functions like a propulsion system. For the first time, scientists have been able to register measurable thrust towards the Sun with such precision that it can compete with the thrust produced by spacecraft engines. This phenomenon raises questions. Is it the result of natural processes or something artificially created? The likelihood of its trajectory being so perfect while passing near planets and synchronously with them is so low that some researchers refer to this event as excursions through our solar system. If comets are not supposed to behave this way, what are we actually observing? And why will we not be able to witness the most astonishing maneuvers of Atlas when it disappears behind the Sun in the year 2025? On the 1st of July, 2025, the Atlas telescope located in Chile recorded a faint streak in the night sky. The data did not just hint at something new, they literally screamed about it. Soon, astronomers around the world confirmed that this was indeed only the third discovered interstellar object, now officially named 3I Atlas. Atlas stood out not only for its speed, but also for what happened next. When images began to arrive from the Space Telescope and ground-based observatories, something seemed strange. The tail, which is usually directed away from the Sun, in this case pointed directly towards it. This was not a fleeting flicker or play of light. Over the course of several days, and then weeks, the tail directed towards the Sun remained stable, contrary to all expectations. NASA, in its official statement, referred to this phenomenon as a valuable scientific mystery, trying to avoid hasty conclusions. However, behind closed doors, the wording was much less cautious. Astronomers characterized such behavior as unprecedented. A comet should not behave this way. Internal notes from the research group, later voiced in interviews, compared the direction of the tail to the operation of a rocket engine working against gravity. For the first time, the idea that the comet was actively moving rather than simply drifting was seriously discussed. Careful astrometric tracking, which measured the object's position relative to the stars, confirmed the incredible. Atlas was not only moving at high speed, but also accelerating, with the direction of that acceleration perfectly aligned with the direction of the tail towards the Sun. The force was constant, measurable, and frighteningly precise, comparable to the thrust produced by some spacecraft engines. In public, NASA emphasized the need for additional data. In private conversations, even the most experienced scientists admitted that they had never seen anything like this. 3 interstellar objects, one of which has a tail that defies all known rules and boasts a record speed that leaves others far behind, created the perfect conditions for unraveling a mystery capable of testing the limits of comet physics and perhaps the boundaries of our imagination. Precision is the foundation of orbital mechanics. For several weeks, specialists from NASA and the Jet Propulsion Laboratory continuously updated their models with new data on the 3 objects. Conducting numerous orbital calculations, they relied on unedited astrometric data. The expectations were straightforward: a pure gravitational trajectory determined solely by the Sun's pull and the known masses of the planets. However, the numbers stubbornly resisted. Each new measurement, whether from ground-based telescopes in Hawaii and Chile or from spacecraft like Hubble, recorded a barely noticeable but persistent deviation. The object did not follow the trajectory dictated by gravity alone. The problem was not due to data errors or miscalibrated telescopes. The residual deviations, tiny differences between predicted and observed positions, grew larger with each passing night. Analysts tried every standard method. They accounted for solar radiation pressure, gas outgassing in the usual manner, even errors from background stars. Nevertheless, to align the model with reality, a non-gravitational force directed almost exactly toward the Sun had to be added. This significantly improved the fit. Statistical tests, including the F-test and information criteria, left no doubt. Whatever was propelling Atlas, it was real and measurable. The calculated acceleration was about 4 millionths of a meter per second squared. This may seem insignificant, but over a few weeks, it was enough to deflect the comet by thousands of kilometers from a purely gravitational trajectory. For comparison, the thrust per unit mass corresponded to a gentle but relentless push from the same engine that sent the spacecraft on its asteroid search. However, here the vector remained constant, always directed toward the Sun, aligning with the orientation of the bright, narrow tail visible in images. Monte Carlo simulations conducted by independent teams confirmed the reliability of this data. Even accounting for possible sources of error, the direction of the additional thrust remained within 15 degrees of the solar axis in more than 99% of cases. This was not a random gas outburst or a temporary flare. It was a constant directed force, tracked over dozens of nights and thousands of data points. The conclusion was clear. The three objects were experiencing measurable acceleration directed toward the Sun that could not be explained by gravity or the usual physical processes of gas outgassing by comets. These figures prompted the scientific community to consider the next step. If this is not a coincidence, the probability of such a trajectory with such force requires deeper investigation. The mystery has shifted from the realm of visual oddities to the sphere of solid, quantifiable facts. The numbers behind the journey of 3I Atlas were as alarming as its behavior. Its trajectory almost perfectly aligned with the plane of the ecliptic, along which the Earth and all major planets revolve. For an alien from another galaxy, this would be akin to trying to thread a needle in space. Most interstellar objects arrive at various angles, bypassing the orbits of planets. However, Atlas's trajectory astonishingly navigates the solar system, moving in the opposite direction, as if countering the usual flow of planets. Statisticians from the Jet Propulsion Laboratory conducted simulations, inputting millions of modeled interstellar objects. Only a tiny fraction, less than 1/10, came close to the ecliptic. The probability that a random object not only enters the solar system, but does so along a path nearly coinciding with a planet's orbit is so small that even the most cautious analyst begins to doubt. Atlas's orbit allows for observation of several planets, providing a tour of the inner solar system, which seems too convenient. The data not only hints at incredibility, but demands explanations. Oumuamua was the first. In the year 2017, astronomers noticed an unusual elongated object leaving the solar system and moving faster than anything ever observed in our planetary system. But despite its speed and strange shape, the real mystery was its motion. Oumuamua deviated from its course, accelerating in a way that could not be explained solely by the force of gravity. It had no tail, no invisible jets, nothing that fit the classical description of a comet. Debates flared up quickly and heatedly. Some claimed it was exotic ice releasing invisible gas. Others, including Avi Loeb from Harvard, went further and published a paper questioning whether Oumuamua could be a solar sail, an artifact rather than just a coincidence. Most scientists dismissed this idea as premature, but the question remained. Could an interstellar visitor be something more than just a rock? With Atlas, the stakes have risen even higher. Unlike Oumuamua, Atlas displays its presence with a bright, constant trail that resembles an engine more than a tail. The name Loeb is once again at the center of discussions. This time, he urges the community not to dismiss the impossible too quickly. In a new preprint, he suggests that Atlas could be a sample of an artificial engine. Although he has made no definitive statements, most astronomers remain cautious, insisting on natural explanations. However, this pattern is hard to ignore. Each new interstellar object raises more questions, and the answers become increasingly strange. If Oumuamua was a whisper, then Atlas is a thunderclap, a cosmic mystery that cannot be unraveled quietly. On the 29th of October, 2025, when Atlas approaches the Sun, the most powerful observatories in the world will be ready, only to fall silent afterward. For nearly 48 hours, the object will be hidden behind the Sun, lost in its dazzling brilliance. No telescope on Earth, no space probe, not even the Hubble Space Telescope or the James Webb Space Telescope will be able to track it through this wall of light. The obscuration will be complete. For mission planners, this is a terrifying period. All calculations and predictions come to a halt at the edge of the solar disk. At this critical moment, any change, even a slight one, in the speed or direction of Atlas may go unnoticed. If a maneuver occurs, a sudden decrease in acceleration, or an unexpected burst of activity, no one will record it. Scientists can only watch as the data disappears and wait in anxious silence. Will Atlas remain on its predicted path when it reappears, or will it change course, or perhaps leave behind a new mystery? For now, the object keeps its secrets in the space we cannot access. In July 2025, NASA confirmed that the 300th interstellar object, Atlas, had been detected in our solar system. Several observatories recorded a persistent tail directed toward the Sun, which is a clear violation of the usual laws of physics for comets. Detailed astrometric observations show the presence of non-gravitational acceleration, creating thrust comparable to known ion engines of spacecraft. Its trajectory nearly coincides with the plane of Earth's orbit and passes near Mars, Venus, and Jupiter. According to some sources, the probability of its appearance is 1 in 20. These facts challenge accepted models and resonate with unresolved mysteries that emerged in 2017. However, important questions remain. What mechanism drives the tail directed toward the Sun? Is this a natural phenomenon or evidence of something artificial? When the 300th Atlas disappears behind the Sun during perihelion in October 2025, the most critical moment will occur out of our sight. As NASA and the global scientific community continue their research, one thing is clear. Our understanding of interstellar objects and possibly our place in the cosmos is being reevaluated in real time.